manager of the Makerspace. Thanks for coming to the session. We're going to give you an introduction as to what we do here and give you an idea about some of the cool technology that we have and when you might use it for future living. And basically, the Makerspace at Salford is all about teaching the tools that we have here. So we have things like 3D printing, laser cutting, electronics development, and then we have more high-powered machines like CNC milling, water jet cutting, and that sort of stuff. And we're going to be taking you through the 3 different areas that we have in the university at the moment, which is downstairs in Newton building. We have 2 rooms in the basement, which you can pop into whenever you like. It's a drop-in place. We take you through how to use the technology, how to use the software, and then we'll let you get on with it and learn through failure, basically, because it never goes right first time. And that's an important part of the Makerspace ethos, is to learn through failure. We will then move on to the Morson Engine Room, where we have the more industrial kit. And then lastly, we're going to go to our greenhouse, where George is going to talk to you about something called FarmBot, which is looking at a new way of urban agriculture. So down here, we have the print hive behind me. These are 3D printers which print in plastic. So if you're unsure or haven't seen any of the parts that they can produce before, then generally what you can make is solid plastic parts like this, and you make them from a digital 3D model file. When you're printing in plastic, it starts at the bottom and then builds layers up, and you can print to different resolutions. So you have things like this with the resin printers where you can print really fine, and then you have your more kind of rough and ready prototyping parts that you can print. You can also create decorative parts. So things like this, Leo the Lion, which was printed on the Ultimakers that we have behind us. And the great thing about these machines is they're very easy to use. So once you've learned how to use the software, you basically just press print and then you wait for the end result. The process of learning to design correctly is where the effort goes in. And that's something that we teach the students to do through courses and also in curriculum as well as out of it. The 3D printing side is fairly cheap, and so if you're producing a part such as the lion, that might cost in the region of £1 in material, and that allows you to iterate your designs. So you can print one, you can test it, you can change it, and then you can improve on it, and that's what we're all about here at the Makerspace. As well as 3D printing in plastic, we can also 3D print in metal, but Aidan will talk to you about that in a little bit of time. Right, we're going to move over to laser cutting now. So I'll just move my camera and then get into position. Okay, so laser cutting is really complementary for 3D printing because it's much faster. Laser cutting, if you're unsure, is a way of cutting through flat sheets of material using a laser. And you can create parts that are made out of flat sheets. So if you want to create things like an architectural model, then you can cut plastic very accurately and you can glue together so you can create cool things like this. We also have some more artistic use for a laser cutter. So you've got things like creating maps, and you have this is an example of a prototype part which was made for a project on the tree trail, which is outside in Peel Park, which allows you to go around and follow QR codes to be able to track the different trees in Peel Park. The laser cutter works by burning through material, so it's either burning it or it isn't burning it, so you can't apply color or anything like that, but it is very simple to set up and very simple to use. You might combine 3D printing and laser cutting into a project like this, which is the Spirit of Salford Award, which is going to be given out for this year. And you can see the 3D printed elements that are together with a laser engraved wooden piece. As well as laser cutting and 3D printing, we have other digital fabrication technologies here. Vinyl cutting, we've got the CNC machining, which we're going to be looking at later. But we also have electronics development. So if you've got a project and you want it to have a bit of intelligence, then you'll need to use something like this, an Arduino, to be able to program something like a lighting system or a sensing system, which can be used for the FarmBot, which is the last machine that we're going to be looking at today. Aside from that, it's an open space, it's a drop-in space. You can come down, you can use the kit, and we can teach you how to do it. What I'm going to do now is pass over to Aidan in the Morson Engine Room, and he's going to take you through the technology that we have there. Over to you, Aidan.
Okay, hi. So my name's Aidan. I'm one of the technicians here at the Makerspace, and I'm in the Morson Engine Room, and this is where we put the really heavy-duty industrial-grade equipment. So right behind me here, this is our water jet cutter. It'll cut sheets of material 1.2 meters square, and it will cut it using high-pressure water. It mixes in a bit of garnet, it's essentially sand, into that water, but it uses 45,000 psi high-pressure water. And whereas the laser cutter, it kind of burns its way through the material. Our water jet, it'll sand through it, and that means that we can cut things. You know, we can cut steel material all the way through. We can aluminium, really thick plywood, that kinds of thing. And just like the all the machines down in the makerspace downstairs, we'll teach you how to run this equipment. You know, if you've got a product that you want to launch, if you've got some, you know, particular ideas for something that you want to see happen, it could be, you know, schoolwork, uni work, or just an idea that you need a new sign for your garden. Then come and see us. We can teach you how to run the machine, and then away you go. So this is really powerful. It will cut through literally anything except for toughened glass, because it shatters, because that's what it's designed to do. But other than that, it'll cut through anything. Also in this room, we've got a new addition. So this is a 5-axis CNC mill. Normally, you'll find that a CNC mill that has 3 axes, it'll move forwards, backwards, left to right, and then up and down. But where this is a little bit different is that it can and tilt things. The thickness of the material is that you can cut on the water jet is limited only by however long you want to wait. We can cut through material this thick if you really want to, and even thicker. As long as it fits underneath the gantry, which is probably about 250 millimeters or so, you can cut it on the water jet. And that's for pretty much any material. You only need to take into account taper, because the longer you're cutting in one particular place, the more the beam will kind of fan out. We can tilt the head over. It's got a 5-axis on the water jet as well, so we can tilt the head over to get rid of that taper in one axis or another, but it just takes a little bit longer. It's a 5-axis machine. We can create very complex metal parts like this. So this is a part for the Salford Racing team. They're building a race car from scratch. This is part of their wheel assembly, and we can make parts like this in one go, straight off the machine, even though it has features all over. Okay, so we can also take parts like this. Normally, you do all of the work on the top here. You drill the holes, and then you take it out of the machine, turn it over, put it back in, drill this hole all the way through here, turn it around, drill this other hole. But we can do all of this in one by using the 5-axis functionality, by tipping the workpiece over. And this saves a lot of time and money, especially in prototyping, because you don't have to create custom fixtures for every single part that you're creating. And then just behind my massive head, just here, so this is our 3D metal printer. Okay, so downstairs we've got plastic metal printing, and this is the sintering oven, which will turn metal 3D printed parts into solid metal, and that's pretty cool, because you can create a lot of really complex shapes, which would be difficult to create in any other way if you were to either machine it, say, or do it by hand. So we can create really complex structures inside parts, and also use some really exotic materials, which would otherwise be cost prohibitive to turn you sideways a second. It would be cost prohibitive to work with otherwise. So as an example of that, we've got a prototype part here. So this is a prototype part that we created for the civil engineering department. Okay, so there are a lot of complex compound curves on this part. This is printed from stainless steel, and it is 98% solid. And it comes from the printer, which is just here, just there. So it prints with metal powder inside of a plastic filament, and then it will you run it through the sintering oven, it burns off that plastic, and you're left with whatever metal was in the filament. So we can with 17.4 stainless steel or Inconel, and these are typically very difficult to work with during the rest. You know, if you were to actually machine it using a traditional subtractive manufacturing method. So we've moved rooms. You might have noticed, tipped you on the side there a little bit to get through the door. This is what we call the clean room. This is where we have a lot of the metrology equipment. So just here, this is a laser scanner. So if you have something which you want to get into the computer, you know, you've made something and has a really organic shape, you can't quite CAD it because it's a little bit complex. We can scan it using the laser scanner, or we can get that data into CAD. This is really, really good for customizing products for, you know, say healthcare use, or maybe, you know, you've got the dentists use machines a little bit like this quite a lot. You know, you bite down on those on that gummy putty stuff, and then they'll scan it with a laser 3D scanner. Doesn't look quite like this, but you know, you get that data into the computer, so you can do whatever you want with it. Just behind me here, so this is what we call a coordinate measuring machine, a CMM, and it's a 1.5 tons of granite. It's very, very rigid. It's very, very stable, and you can get some very, very accurate measurements out of it. This is used a lot in industry. You know, you're making 100 parts or something. You want to check it. You know, you want to check every 10th part to make sure that you're getting a reliable process in place. And then further on down this line, we've got some microscopes. So, you know, sometimes you want to have a look up. You want to have a look close up at things inside the, you know, up to 1,000 times optical magnification. We've done some reverse engineering using these. So whatever you want, really. We're open for, like we said, prototyping, as well as, you know, university work and personal work. So if you just want to learn how to use the equipment, then that's fine. That's what we're here for. We'll teach you how to use it. So that's it from me down here in the Morson Engine Room. I think we're going to go up to George in the greenhouses on the roof of Newton Building. And he's going to teach you, he's going to introduce you to our robotic farmhand, the FarmBot.
Hi everybody, my name's George. I'm up in the greenhouses on top of the Newton Building, up on the 2nd floor. And as Aidan was saying, this is our FarmBot. Our FarmBot is basically built onto this, it's a 3 meter by 1.5 meter bed that we put up here. You might be asking what actually is a FarmBot. So a FarmBot is a gantry-based farming system. So when I say gantry-based, we have this section here, which is our gantry, which allows the head to move back and forth, and then the whole gantry will move up and down. So to give you a little idea of that, I'm just going to run a watering cycle on the plants. So just in the front of the gantry, I've got some chives that have been growing. We actually had a student doing a research project about growing plants, growing food in this sort of machinery for food banks and things. So I'm going to hit run. It's a little bit noisy, but kind of demonstrate the idea of what it actually is doing. So as you can see, the machine will move over to the top of the plant, and then we give it a sec. And then it will deposit a accurate amount of water. So this is one of the great things about these sort of bits of technology when it comes to farming, is that we can control very accurately how much water is being dropped onto each plant, and obviously log that and keep track of all the water that is being used on this machine. To give an example of this, we had a spinach crop growing on this, which grew for about 30 days, and in that 30 days we worked out that we had actually only used about 27 litres of water to go from seed to a mature plant ready for harvest. So in sense of water usage of plants, that's great, and means that we're never wasting water by splashing it around in areas where the plants aren't going to get to it, or it's just going to soak and disappear down into the ground and not be used. So this allows us to provide quite accurate watering in that sense. So we'll let that just carry on doing its thing. It's the great thing about CNCs, these sort of robots, we can just leave them to get on with it. I don't need to be here. Watering is obviously what it does most of the time and is kind of the main task, but there are a lot of other things that we can do with this machine. So on the head of the machine is the watering probe at the moment, but we have additional probes. So this is the soil sensor. So what this does, the machine will go pick this up from a tool rack, move to a predetermined location, and plunge this into the soil, which will give us a moisture reading of the soil in that area. Sorry, it's quite noisy when it moves that way. With being able to basically map the bed and work out how wet all the soil is in the bed, and then we can use that to adapt our watering strategies. So at the moment, we're just using this. We're going from plant to plant. We're giving them, it's about 2 seconds of watering, which actually works out to be about 150 ml of water per plant each time it does that. And this is set to do on a sort of schedule. So we can set this up so it runs in the morning, waters the plants, and we'll repeat that and can do that other days. So while scheduling watering, we can do soil checks to gather on that. Other tools that we use for is actually when we come to planting a new crop. We need some way of transferring the seeds from one place and putting them accurately onto the bed where the machine knows they are. You could go through and you could put them in by hand, but why put them in the hand? And when you've got a machine to do it for you. So we have this device, which is our seeder, and this uses a needle and a vacuum pump to move over the seed bins, which come in a couple of types. We have sort of larger cups like this that hold pockets of seeds, or if we've got multiple crops that we're planting, we have smaller seed bays that the machine can go pick from. So the head will move in, drop in, turn on the vacuum, pick up a seed, take it to a location, and plant it into the ground for us, which then is logged. It gives us the age of the plant and then build into the watering strategies for the rest of the machine. Obviously, we have our machine inside a greenhouse, so one of the things that we don't really run into too much problem with is weeds. But these machines are designed to also be outside. You can have them in any sort of place. They can be set up very easily, either on a bed, or they can actually set up directly on the ground using light feet to hold the gantry in place. So one of the things that these machines also can do is actually tackle weeds. So on the head of it, there's also a camera. The camera will map and look at every part of the bed, and then it will take this slightly medieval looking device, which is our weeding tool, and move out and drive, basically crush any weeds back into the soil, kill the leaf structures of the weed and thus in turn the weed. And again, this is like the watering. We set this up so that it goes every, say, 5 days, for example, go try and find some weeds. It will go, it'll have a look, it will find some, if it finds a weed, it will deal with it. If it doesn't find a weed, it just goes back to home. It also actually, if it finds a weed or finds something out of place, it sends me an email saying something's out of place, there's a weed here, and it will take a picture and send that to me. So if I'm not here, I'll get a little message saying, okay, there's weeds in the bed, I need to have a look a bit closer and tell the machine to go do a few more strategies to take them out. So things that we've been growing in here, currently we just water the chives. Need quite a lot of water. I've actually harvested off these chives already once since they've been in, and they've shot back up in the last few weeks. Obviously it's quite sunny up here, so they do quite nicely. But it just tilts you around a little bit. So probably looks a bit dense here and it's quite hard to see, but we have a bank of carrots in the front here, a pair of tomato plants, some sweet peas, and some beets in the back. So this is one of the other big advantages with this style of growing, is that we can arrange our plants in the bed to optimize how densely we pack everything for the leaf structures, and basically lay everything out. And it doesn't all need to be the same plant, because we can set up the machine to tackle plants. So something that might require a lot more water, we tell it that this plant needs more water in its cycle, so it might go over to that one and water for 4 seconds rather than 2, and so on and so forth. So we can always work out where we're sort of needing to deliver more water. So that is kind of FarmBot in sort of a nutshell. Other things that we've got going on in the greenhouse at the moment. At the head of the FarmBot, we've actually got a pair of micro hops plants that we are currently just experimenting with growing up here to look at possibly taking these and then eventually transplanting them into some other experiments and things. But at the moment, they're another sort of set that we're growing alongside our micro hops plants, which have a really good name, which is Prima Donna. We also have our more traditional hops plants that we're growing as well up here, which are pots. These are actually hooked into a watering system that is hooked up onto a timer control, which basically will water them regularly for us. And through in the other space, we've been overwintering bedding plants for Peel Park, which we've been looking after, which I should be actually be going back into the beds in Peel Park in the next few weeks. So that's kind of everything from the greenhouse. Obviously, we're looking to develop more things in this space, do more projects with the FarmBot, and one of the things that we're quite excited about this is all this hardware is open source, so it's very easy to adapt and change and add new things in. So one of the things that we're quite capable of doing is, like, say, if we're finding something like this weeding head isn't quite doing what we need it to do for our situation, we could go down, we could 3D print a new prototype, attach it to the head, get it working, get it running. Same with the seeding modules and the sensors. We can 3D print or take down 5-axis if we need a more robust part. And again, also with the actual physical hardware on the machine, we can very easily take the equipment that we've got in things like the Morson Engine Room or our main space downstairs and modify and adapt this to basically build it into a bigger, better platform. So yeah, that's kind of everything from me up here in the greenhouse. I believe I'm going to pass over to Mike Hardman now. So thank you for listening.
Yeah, hopefully everybody can see me. I'm Mike Hardman, and I'm just going to show you with a presentation very briefly that connects to what George was just talking about and gives you some of the wider context about the work that we're doing linked to the FarmBot at the university. So no more than 10 minutes, I promise you. This is not PowerPoint for death. But we do have a research unit that connects really well to what George was just speaking about and the wider wonderful work going on within the space too. Some of our students have been working, as I mentioned, with FarmBot, and there's a hub at a wider university level that brings together nurses, built environment professionals. I'm a geographer, environmental scientists, and beyond as well around this idea of urban farming particularly. And there's more information as I go through that you can click on in your own time and have a look through about some of the exciting projects that we're working on and hopefully getting FarmBot involved with as well. So just give you an overview of some of the work that we're doing and the importance of that FarmBot work and the wider urban farming work at the university. As we know, cities are getting bigger, a lot more distance from their food sources. So this type of high-tech growing is so important, and particularly with COVID and the pandemic recovery, the idea of growing our own and having a more resilient food system is so important at the minute and high on agendas both at a national and international level. And so again, that technology you were just seeing there's a lot of interest in upscaling that, embedding that within projects and looking at how we can really tackle these issues around the food system by growing more, particularly in our urban environments. And at Salford, we're doing a lot of this. We're working alongside not just the high-tech element of urban food growing and urban farming with things like the FarmBot and similar technologies, but also working on a more conventional basis with things like community gardens and allotments and large-scale urban farms as well, and even rooftop growing, which is really, really popular in the minute. There's a lot more interest in this as well. I'm sure many of you have seen these before. There's so much of this going on right now, and a lot of it, again, was in the news during the pandemic because these sites responded to issues with our food system. We saw evidence of high-tech hydroponic sites growing more food to supply people who were vulnerable, shielding, weren't able to get produce from supermarkets or from the usual kind of spaces. On a more conventional level, we've seen things like in Todmorden, incredible edible, and the power of these projects, what they can do socially, but what they can do economically and environmentally as well. And FarmBot has the same potential here. You know, technology like that and research around that to upscale it can explore ways of creating jobs, of tackling, again, that insecurity with the food system, of creating more resilient cities as well in the future. There are projects over at our colleagues at Liverpool University, Farm Urban, who are doing this as well at scale, growing underground near Albert Dock, all the way through to down south where you've got in Bristol, aquaponics at scale as well. So there's a huge appetite for this going forward, a huge amount of investment. And at Salford, we're working across the globe, not just with FarmBot, but globally. We're doing work in Africa. I do a lot of work myself in South Africa. We've got work in Nigeria, in Kenya as well, all the way through to the United States and Canada, exploring the potential of this technology and the potential to transform food systems. We've done a lot of work in Manchester. This is some of our work in Wythenshawe with a lottery project, for example, where we were working with community growers. So embedding a lot of this knowledge in the community, working with the community to look at issues with growing and soil quality as well, looking at things like polytunnels and other high-tech options that we might be able to use in these communities to upscale food production. I do a lot of work in the States on the larger scale rooftop farms as well, where there's a huge appetite for this and again, creating jobs and really impacting on cities at scale here. So if you go to New York City, these types of rooftops litter the environment. A lot of work going on there to a much larger scale than we currently see perhaps in the UK. If you're interested, there's loads of reading that you can look at. I can send this PowerPoint around afterwards if needs be, but we've published quite a lot in the British Medical Journal, all the way through to books on urban agriculture and urban farming. And so if you're interested in the academic side as well of some of this technology, feel free to have a look through some of our publications or some of the documentaries that we've done over the years with the likes of the BBC or other kind of media bodies as well. The Conversation, Independence, and so on as well, around the potential for this going forward. Projects that we've worked on, we've got quite a lot of funding at Salford from places like local authorities to housing groups to private property developers who are interested in things like FarmBot and associated technologies. Just give you one example here of an exciting project that's happening in Oldham that is looking at FarmBot type approach, and Northern Roots here, where they've got this £31 million master plan, and they want to upscale urban farming to a degree that really hasn't been seen before, at least in Greater Manchester. So a lot of exciting stuff happening just over the road from the university, even in Pendleton, which is literally just opposite where the campus is. There's a huge appetite there for urban farming, a huge investment there in community growing as well. So this type of activity isn't just happening at the university and on campus, but there's a lot going on elsewhere. This is from one of our research projects a few years ago where we toured the country, looking at different approaches to urban farming. So in the top left, you've got aquaponics on a rooftop here in Liverpool, all the way through to the bottom left here, which is Wythenshawe Community Farm, and another project here in Birmingham and London that have been working on this concept for 30 years plus. So this kind of gives you an appetite or a flavour of what we do at the university, some of the wider research that we do in terms of barriers to this, huge barriers around financial barriers to a lot of this activity going on. This is from some of our research that we did and was commissioned to do by Pendleton a few years ago, where we looked at barriers to urban farming and the fact that financially there's still a lot of issues with regards to the practice. Barriers also to do with large-scale urban farming in cities, and this is awful what happened in Wythenshawe a few years ago, where they've got a lot of animals on the urban farm, and obviously that wasn't great in terms of vandalism, and there's been issues like that up and down the country in many other projects as well. But more recently, and linking through to FarmBot and what George was talking about, there's a huge appetite at the minute for things like this, which is freight farms. It's about £86,000 for one of these units. But we've worked on quite a few projects that have looked at putting one of these in place. It helps to get people involved. Younger people want to get involved as well because technology is quite cool, quite different from an allotment or just a community garden. This isn't just small scale as well. If we look in the UK, this project called Planet Earth, £157 million. It's a hydroponics project. So they can grow tomatoes and other types of produce all year round in an enclosed environment without soil, using high-tech systems. And it's more resilient. They work with supermarkets as well to embed this technology and to bring the produce to market. In this case, you can see an interview with one of the lead people at Planet Earth from a project that we did, that was saying that, it's still tricky, even with this size of project, because of working with the supermarkets and the volatility of the food system, really. There's a lot of work to be doing there to really upscale this high-tech growing. We've seen in Salford where there's been some wonderful projects in the past that unfortunately have failed because of financial reasons. And we've seen in Wigan, for example, where they had the vertical farming system and they wanted to do something similar to FarmBot, but at scale, with aquaponics involved as well. Unfortunately, that no longer exists, and that project is now no longer around. And so there's a real need there to look at the models that we're embedding here, the technology we're embedding as well, and making sure that it's resilient. And also the types of produce that we can grow. And I think this is what's unique about FarmBot, is that it's much more versatile than a lot of the other systems out there. It can be retrofitted onto conventional growing spaces, and it can do a lot more than some of these more radical technologies you might see that are quite limited in what they can grow. As George was talking about, the work that's already going on with that raised bed, pushing boundaries there, and something that you can see being retrofitted onto many other types of urban farms around the country. Moving forwards with the SalfordCare and Urban Farm Hub, we're doing a lot more work in North America with our colleagues. We're doing a lot more work around high-tech growing. This is the Geodome in Wythenshawe that we've done a few documentaries on, and a bit of research over the years. That is about £100,000, and it's an aquaponic system indoors. Again, they've got the fish waste, which is recycled through and growing there. Again, getting the community involved and getting younger people involved in this particular space. We're doing a lot of work around making sure that there's policy tools and funding available to grow this type of technology as well. My colleague Michelle Howard, for example, led a project only a couple of years ago that was looking at a national code of practice to get things like urban farms upscaled and to make sure that there's more support for them going forward. We've seen planning guidance and other types of documents as well pushing forward this practice. But if you're interested in this or anything related to FarmBot, I'd urge you to have a look at Carrot City, which is one of the projects that we work with some of our Canadian researchers. And if you go on the website, Carrot City, you can cycle through and see a collection of exemplars of how to do this at scale across the world. Similar to FarmBot, similar types of technologies in different countries from the Middle East all the way through to Africa and beyond as well. But hopefully that gives you a flavour of what we do in the SalfordCare and Urban Farming Hub and how it links through to FarmBot and the wonderful work going on there as well. These are my contact details if you want to get in touch or if you've got any questions afterwards. Otherwise, I'll be quiet for now and I will hand back to the host to take over from.
Okay, thanks for that, Mike. We're back to the Makespace. Is there any questions from anyone who's just listened to any of that and wants to ask about anything that either we've been doing or Mike's been doing? Okay, one for you, George.
So with the FarmBot, currently, obviously, this version that we've got, we're running in just the greenhouses to kind of benchmark and test this equipment and kind of work out what how we might want to sort of develop it and take it further as a platform. So I think, I know it would be potentially could be kind of a nice thing to look at actually taking these sort of systems and I know either developing them into sort of faster running, more compact systems, or kind of wrap them up into like a little bit more of a sort of more user-friendly package, because there's a little bit of like learning that's involved to put these together and get them up and running. But like they are like they have been designed very well, and the instructions for building these things is very good. It's but yeah, I think as we continue working with it and sort of discovering things that we might enjoy, improve upon, I think yeah, we'll sort of just continue looking at developing it really. Does that kind of answer your question, or? Okay, thanks.
Hi, Tom. No, we don't have a 3D printer or a PCB printer, sorry. We typically just use services like OshPark in the US or a PCBWay, that kind of thing. There is, in the electronic engineering department, they have a PCB milling machine, but it can be a little bit temperamental sometimes. And I've always found it's just a little bit better to wait 2 weeks until you can get it from OshPark, really, even though it's a little bit more expensive, because it won't do things like vias and silkscreen and things like that.
Okay, if there's no other questions, then thanks very much for joining the session. If you want to get in touch with the Makerspace directly, you can just email makerspace@salford.ac.uk. And otherwise, if you need to get in touch with Mike, then I'm sure the details will be sent out with the presentation. Thanks very much.